the best way to learn or master anything is by practicing. So today we came up with a project heart disease analysis for you so that you can practice your skills or learn the skill of data analysis on a dataset. So what we'll do, we'll take the dataset, we'll see what is in the dataset, the rows, the column, we'll pre-process it, we'll find couple of a relation, we'll find the correlation, we will find the other matrices, and at the end we'll make some visualizations out of it. So that's end-to-end thing that we are going to do in the series. So without wasting any time, let's jump into it, and I'll see you at the end of the video. So this is a new project that we are starting about heart disease failure analysis. We are having the data set on Kaggle. So what we are going to do, I'll first of all introduce you to the Kaggle. What is Kaggle, how to set up your account there, and which data set we are going to use. So this is basically the session for that, and after that I'll also tell you how to load the data set in a Kaggle environment so that we can code. So that's pretty much it, and let's jump into it.
So we have discussed about a lot of things so far, but this time we are going to discuss about heart failure prediction dataset. Okay, we are going to do the EDA. What is EDA? EDA is Exploratory Data Analysis. We are going to perform EDA on this dataset, which is heart failure prediction. Okay, so this is the link from where you can download the dataset. Okay, it is from Kaggle. Kaggle is a platform where so it is a must visit platform for data scientists, because here we are having a number of data science, number of competitions going on, so you can upload your own data set as well. Okay, so this is the data set that we are having. Okay, and let's see what are the different things we are having in the data set, and this is the whole documentation. So here you can see we are having different attributes. Age is one attribute, sex is another attribute, chest pain type, which type of chest pain they are having, and here we are having TA, ATA, and NAP, ASY as well, asymptotic, non-anginal pain, atypical anginal, and typical anginal. Okay, so these are the terminologies that means a person from the biology background must understand in a better manner. But yes, these are the four types of chest pain that we are having in the data set. Apart from that, we are also having resting BP, which is the resting blood pressure. What is that blood pressure we are having? We are also having the cholesterol, okay, in mm by dl. This is the measurement that we are having. Apart from that, we are having fasting BS, which is the fasting blood sugar level. So we are having different attribute which is mentioned here. Resting ECGs also we are having, which is which is echocardiography. Okay, maximum HR, maximum heart rate, but about the user, because in the column name you cannot write this big name. Okay, so and this is a value which is between 60 to 202. Okay, and we are having some other features as well, and then we are having heart disease. Okay, that means if that particular person is having a heart disease or not. 1 means yes, he is having heart disease, and 0 means not having the heart disease. So these are all the things that we are having about each and every user. Okay, and from here you can see what are the sources from where this data set is taken. Okay, and final data set is having 918 observation. Okay, because total observation is 1119, 272 observations are duplicated, so obviously the final data set is having 909 observation unique. Okay, you can get to the original author as well. So this is how you can read about the documentation. It will teach you a number of things. Okay, and it will also tell you, if you are creating your own data set, how you can actually present your data set to the end user so that everyone can use it. These are the creators for the data set, and this is actually the data set, which is heart.csv. Okay, here we are having age, we are having sex, we are having chest pain type, which is the name of the column. Resting BP is the name of the column, which is for resting blood pressure, and these are all the columns we are having. Total 12 columns we are having. A number of rows are around 1000. It is mentioned here. almost 1000. So what we are going to do, we are going to write the algorithm on this, okay, or do the ED on this. So how I can do it? First option is you can click on download the dataset, but for that purpose you need to sign up your account on Kaggle first. Okay, if you have signed up for that, you just need to click on download and the dataset will be downloaded. Okay, so just save it. Once it is downloaded, you can open it, and this is the herd.csv file that we are having. You can import it directly using Pandas. Okay, sorry. And the second option is you can create your new notebook here only. How you can create it? First of all, you need to create an account or sign up, as I've told you. Then you can directly click on new notebook. Okay, if you click on new notebook, it will directly open a Jupyter notebook for you, which is called as Kaggle notebook. Okay, it works exactly same as a Jupyter notebook. Okay, and the benefit of using it is the whole data set is loaded here only. It is not taking your local resources. It is running on the online Kaggle server. Okay, but otherwise here, if you are using Jupyter notebook, you might have seen here localhost. Okay, this is the main difference that we are having. This is the name of the notebook that I am going to change. This is for heart. This is exploratory data analysis. This is something we are going to do today. Okay, and apart from that, what we are going to do, I'm going to, this is how much time it will take in the beginning. It is, you can write up to 20 GB. Okay, you can also write temporary files in this. Okay, this is the pre-written code that we are having. So what I'm going to do, I'm removing this pre-written code, and let me tell you. So Numpy is already imported. This is obviously something I want. Apart from that, Pandas is also imported because this is a CSV file. If I am executing it, make sure to execute this first line. Okay, if you are executing this code, what you will get? You will get all the dataset files. Okay, that is there. Like here we are having just one CSV file. If you are having multiple CSV files, you will get that as well. Okay, so here you can see the session is starting. It is started. Here you can see we are having 3.2 gigs of disk utilized. RAM is 16 GB that we are having. We are utilizing only 216 MB so far. Once you have executed it, this is the path where the CSV file is. Okay, what you can do, you can write data frame is equals to pd.read underscore CSV, and here we are going to write the path. Execute it, df.head, same, and just wait for it to execute because it is loading the her.csv file. Once it is loaded, here you can see the age is 40, 49, 37, sex is male, female, 80, this is the type of chest pain we are having, this is resting BP, this is cholesterol, and this is blood sugar level, ECG. So these are all the things that we are having. Okay, and from here you can see the path is inside the Kaggle input. Inside this input we are having heart disease failure prediction folder. Inside that folder I am having heart.csv. Okay, this is where the file is located. Similarly, you can go to this output folder as well. If you are having anything to be drawn, you can write in here, means inside Kaggle /output Kaggle working. Inside that you can write anything. Okay, this is my data set that I am having. Now what I am going to do, I am going to do the basic ADA on it, means basic exploratory data analysis, and this is just part 1 where I have teach you what is Kaggle, how you can load the data set on it, and how you can create a new notebook in this so that you can write your code in this. So I'll see you in the next video where we are going to perform proper ED on this.
So I'm hoping you are clear with the concept what is Kaggle, how to set up your account, how to load the data set there, and how to actually create an environment where we can code. Now we are having the data set. So what we are going to do, we are going to analyze the numeric columns but using a distribution plot. It will tell you what is the minimum value, what is the maximum value, what is the overall distribution of the whole column. For example, age. So let's discuss about it and I'll see you on the other side.
So far we have discussed about how to work on heart disease data, how we can load the data in Kaggle notebook. I'm talking about Kaggle notebook this time. This is the data set that we are having, heart failure prediction. And I have loaded this data set. How I'll get to know about this path? This is the path. Okay. Otherwise, if you don't know where this code is, you can just write /Kaggle/notebook, then just write the name of this folder, and inside that we are having this file. Okay. Once we are having this, I'm displaying df.head. This is something we are having. You can also write df. This will tell you the total number of columns that we are having. 918 such columns are there, which is already we have discussed in the documentation. In the documentation only we are having these files. Okay. So now what should be the next question? The next question is, like, we know how to check a particular thing, how to analyze the data set in a nutshell. Okay. But the problem is, how we can analyze the data set and doing the exploratory data analysis. Exploratory data analysis means we are going to check the data set, see how means the columns are correlated, if there is some correlation or not. We are going to like, if I'm talking about age and sex. Okay, in this data set, if I want to check what is the distribution of age. Okay, let me tell you how to check that. For that purpose, I'm going to use a library. I'm going to use a special library this time, which is Seaborn. Okay, Seaborn as SNS, which is just a short name that I am taking for Seaborn. You can take any name of your choice. If it is not imported or installed, so the instructions are pretty much simple. Let me move it from here and paste it here so that it won't make any problem. So what you can write? You can write pip install Seaborn. This is a data visualization library where we can plot the graphs, different kind of plots. Okay, and because here you can see it is already installed, so we cannot do anything. Just delete the cell. Okay, because it is already installed. Now what I'm going to do, once we have imported the CSNS, which is Seaborn library, I can plot a graph which is called as distribution plot or DistPlot. Okay, so let's make our own DistPlot, which is distribution plot. Here you can see it is installed, so let me remove it. Df of head is something we have done here, so let's do here only because I don't want to make mess with the code. So this is the data set that we are having, and what I'm going to do, I'm going to write SNS, which is my Seaborn library. Inside that I'm having something called as DistPlot. Okay, DistPlot. Inside that I'm having multiple columns. On which column I want to make the distribution plot? I want to make it for the age column. Okay, so I'm going to write df of age. This will give you the age of all the uh, patients that we are having. So let's pass it here, df of age, executed. This is the distribution plot that we are having. Minimum age of a person that we are having is around 30. Maximum age that we are having of a person is almost 80 years. Okay, and most of them are from this particular age. Okay, that we what I mean to say is the data set is of, mostly means I would say 90% of the data is from 40 to 70. Rest 10% data we are having. So this will help you to do a basic analysis how the data set is distributed. We are not having the people from age 10, 20, 25. We are not having the people from age more than 75 or 80. That's the basic distribution that I have seen, and this comes under data analysis as well. Okay, We can also plot some different kind of plots, like we are having KDE is equals to true. Inside that we can also write KDE plot. What KDE will do, KDE will plot a straight line, okay, which actually fits the whole data set. So that's totally up to you. If you want to add KDE into this, you can use KDE as well. Okay, again we are also having something called as a histogram. Okay, so let's see. So let's add age here. So KDE, let's make it KDE is equals to false, because now the line is not there. Okay, and let's make histogram is equals to true, and let's see the output. Okay, so actually it histogram works in DistPlot, not DistPlot. So because here we are having just one option to use the KDE. Okay, if I am executing this one, okay, so we are having KDE, but here I need to write DistPlot, because we are having two different functionalities. DistPlot is for the distribution. In DistPlot we are having different kind of functionalities that you can use. You can use histogram, you can use rug plot, you can use bins as well. Okay, so for that purpose you need to remember what are all the functions that we can call. KD is equals to false, and here I am writing histogram equals to true. Execute it, and here you can see it is a histogram now. The lines are gone. Okay, and apart from that we can also use RUG, which is rug plot. If I am writing rug plot is equals to this and this is equal to false, so this will make the plot in rug format. This will create a density function. Okay, in which particular area the density is there, like here we can see from 25 to 78. Okay, so that depends upon totally the use case. If I want to display more than one graph at a time, RUE. So this is the graph that we are having. Okay, so this is a distribution graph where this is how it looks in terms of KDE. This is the histogram, and here let's suppose if I want to make some bins out of it. For example, the minimum age that we are having is like if I am plotting this graph and removing all the other things and writing bins is equals to 10. So it will divide the whole data set into 10 bins, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and it will make the plot in this manner. If I am writing bins is equals to 5, it will make only 5 bins out of it. Okay, so that is totally up to you how you want to change it, how you want to manipulate it in such a way that you will get the results. Okay, so if I want to make 30 bins, the more bins you are having, the better density that you can have. Okay, and the graph looks something like this, because this is and if you are removing the bins, it will take the by default how many unique values you are having. This is how the graph will look. Okay, so this is something we have discussed about distribution plot, how distribution plot work and how we can use it for age. Same thing, we can use distribution plot for sex as well, like how many males are there, how many females are there. But for that purpose, rather than using this graph, because here we are just having two bars, okay, one for male, one for female. So rather than using bar graph for that, we can use something called as a pie chart. How to work on pie chart?
So I'm hoping you are having a basic understanding now how the overall distribution plot works, what's the purpose of it, and how to use it basically. So distribution plot is done. Now we are going to discuss specifically about pie chart, where we are. So it is used basically whenever we are having less number of categories. For example, 3, 5, 7 up to 10, because After that, it would be really difficult for you to analyze whatever is happening. So in this case, we are going to plot a pie chart based on the frequency. So let's jump into it, and I'll see you on the other side.
So we have made a distribution plot for age. Okay. Similarly, what we can do, as I've told you, we are also having some other numeric values. For example, we are having chest pain, resting BP, which is a continuous value. Cholesterol is a continuous value. Similarly, old peak can be a continuous value, and maximum HR. Heart disease cannot be a continuous value. It is either 0 or 1. 0 means not, 1 means having a heart disease. So let's do the same plot for other columns that we are having. Let's do it for resting BP. Let's see which kind of graph we are having, because it will help you to analyze how the things are going for the data set. Like from this, what we can see, the blood pressure from this data set, the maximum blood pressure that some of them are having is around 200. Okay, minimum is 0, which is not possible. So obviously it would be starting from 70, 75. So from 75 to 200 is the basic distribution that we are having. If I am writing this is equals to false, so this is the basic distribution that we are having. I can also use DistPlot. Let's use distribution plot this time. And let's write this is equals to true, so that we can have a clear cut line, right? So this is how the line is, which is exactly like a bell curve. Okay, that means the data is quite unified. There are some of the value which are above the average and below the average, but this is how the distribution looks. Okay, that's totally up to you how you want to analyze it. So this is the age distribution, this is the resting BP distribution. So from here you can also analyze like 90% of them are having the BP from 120 to 180. Okay, so what other column we are having? We are also having cholesterol. So let's do the same for cholesterol as well. This will also clarify your things about the distribution of cholesterol. So from here you can see the distribution, and the cholesterol for a lot of I would say patients are 0. Okay, but if we are seeing this particular curve, this particular bell curve, so this is where the most of the people lies. Okay, they are having the cholesterol between 100 to 400. This is again a bell curve. Okay, in the normal distribution that we have, this is how the distribution looks. Okay, same distribution happens, sorry, same distribution happens for this which is testing BP, and almost same for the age as well. Okay, so this pattern is following. These are the outliers that we are having before 8, because some of them are having 0 cholesterol. Okay, so that's the reading. We can remove these outlier as well. As we proceed further, we are going to discuss about that. What else we are having? Let's discuss about some other columns that we are having. Apart from cholesterol, we are having uh, fasting BS. Let's take that. What is this fasting BS? So the distribution is either 0 or 1. So they are we have gone for the documentation about the fasting BS. So this is maximum heart rate. So let's do the maximum heart rate this time, because this is just a binary value. Others, this is again following the same kind of bell curve. Okay, means the distribution of the data set is okay. They are following the same kind of distribution, so the because of that it won't create any problem. Okay, and let's do the same with the last one that we are having, which is old peak. Okay, so let's see which kind of values we are having in old peak. Either it is a categorical value or just a continuous value. Move it from here, let's paste it here, and let's execute it. Okay, there's also having the continuous value between 1 to 4, so we cannot take it as the basic distribution. Okay, so let me move it. So these are the 4 uh, distribution plots that we have drawn for the from these kind of columns, okay, where the numbers are continuous. Now the question is how we can do the same but for the categorical one. Okay, when we are talking about the categorical one, okay, so for the categorical one we are having something called as from the data frame only we can use it. Okay, so let me tell you about the how the presentation can be done as well. Like if I want to add something like this is for the distribution plot for numeric columns. This is something we are doing here. So let's write it here. Okay, we are also going to make the pair plot where we can see if or the correlation is there. We are also going to use the correlation methods, but this time we are just using the distribution plot. And here, because we are now away from the distribution plot, so here we are going to pie charts for categorical one, because here we are having a lot of categorical features, and one of the categorical is gender, obviously. Okay, so what we are going to do, we can use data frame, which is my original data frame. I can use group by function. Okay, there's something we have used earlier as well. This group by function will help you to make the groups of what, this sex. Okay, let's take sex here. Okay, so it will make the group of sex, right? But means we are having male, we are having female. Okay, but by what quantity, by which factor I want to make the groups? I want to make the group based on this size. Okay, if I'm executing it, here you can see there are 193 females and 725 males. Okay, so this data set is not balanced in terms of males and female candidates. Okay, there are very less female as compared to the males. Okay, so what we can do, we can means how we can plot this in terms of a pie chart, because pie chart works best in this particular case. So we can use dot plot, because this is data frame, we can directly plot it. Dot size dot plot. Here I need to define which kind of graph I want to plot. I want to plot a pie chart. If I'm executing it, this is the pie chart. This is how easy it is to plot a pie chart. Okay, and here we can also write, like if I want to do, if I want to write the numbers in this as well. For that purpose, I'm going to use auto PCT, auto punctuations is equals to, now how I want to make the punctuation. Okay, for that purpose, this is the symbol of using it, 0.1f. If I'm using 0.1f, so it will go up to 1 decimal place. Okay, if I'm writing 0.2f, it will go up to 2 decimal place. Can we go for 0? Yes, we can go for 0 as well. Okay, so this is how we have make a chart, like how much percent of uh, people out there male and how many of them are female. So this is the pie chart that we have used for the category. Okay, can we do the same for some other category? Definitely yes. So let me take the same, but this time let's use some other category. Let's take chest pain type. We are having four type of chest pains, I think 4 or 5. Let's see, the size would be the same, and here you can see maximum of them are having ASY, which is asymptotic, I think, pain. 5% of them are having this much. So this is the basic distribution about the pains we are having category. This will help you to again analyze, okay, most of the people are having this particular problem. So if any new person is coming, so 50% of the chance that he is having asymptotic pain, because this is a rare pain. TA type of pain is very rare. Okay, so this will again help you to analyze a number of things. So chest pain we have done. let's do the same thing but for the other categories. We are having resting ECG. Okay, let's take this one, resting ECG, and do the same pie chart for this. So we are having different kind of visualization, as I've told you. That totally depends upon what you want to do with it. If you want to make bar graph, so if you are having numbers, bar graph works best for it. If you are having frequency, bar graph works best for it. If you are having categories, if you want to compare 2, 3, 4, 5 categories, these graphs works best. If you are having 50, 60 categories, then we need to use another approach. Here you can see 60% of them are normal, right? Their resting ECG is normal. For 20% of them, it is ST, which is something you can again take the reference from the data set. Okay, and how to do that? As I've told you, you need to go to kaggle.com. Okay, after going to the Kaggle, you need to go to the data set. Once you go to the data set, this is the data set that we are using, heart failure prediction. Okay, so you can go to the data set documentation, and here you can see what is this resting ECG, testing ECG. We are having normal, we are having ST wave abnormal. Okay, and we are also having LVH, which is left vertical hypertrophy. Okay, so these are again the medical terms, so you can go through it. So, and let's do the last analysis that we are having for okay, let's do it for ST slope, exercise, and heart disease. Okay, let's do it for ST slope, because rest of the thing you can do. You're also going to have an assignment very soon on the data set, where you are going to use exploratory data analysis on your data set. Okay, currently I'm just doing the very basic analysis using making the graph, different kind of plots we are having. 50% are flat, 43% are up, and 7% are down. What are these up downs? You need to check about this. Okay, and the last one is the heart disease. Okay, what is the distribution of heart disease that we are having? Okay, because there might be the chances, because we are having less number of women who are having heart disease, there might be more number of people male who are having heart disease. So for this time, let's execute it. So here you can see 1 means the person is having the disease. So there are 55% chances a person is having the disease. And this is not the data set from whole country. This is just a sample of data set. Okay. And from here, you can see if anyone is giving the samples to them, so there are 50% chances he will have a heart disease. But if we are taking the sample from a random village or a town, obviously the chances are way lesser. Okay, because here the only the people that are coming are aware that they might have a disease. Only then they are coming and doing the readings and tests. But here from this data set, there are 50% chances the person is going to have it. Okay, if we are doing the same test on the candidates who are from means basically are normal, so obviously then the chances of predicting or having a heart disease is way lesser. Okay, so this is something you need to take care. We have just do the very basic analysis by taking one column at a time, and now from the next lecture we are going to discuss about how we can do the correlation, finding the correlation, making the heat maps, and making the pair plots. That is something we are going to do in the next video. Take care. Bye.
So, in this lecture, we have discussed about how to work on pie chart, and we have discussed about in a particular case of heart failure, we are having either two cases, either it is possible or it is not. So in this case, we are having just two category, so we can go for a pie chart. Similarly, if we want to go for chest pain, we are having five basic types of chest pain, so we can use that as well, pie chart. If we are having multiple categories like 100, 200, obviously it will not work that great. So for that purpose, we are having some other kind of plots. So we are clear with the concept of we can work on multiple kind of distribution plot and pie chart. Now this time we are going to work on ViolinPlot. What is ViolinPlot? So basically, it is used whenever we are having multiple columns we can take to analyze the thing. For example, if I want to know how many females are there who are having the heart disease, how many males are there who are having the heart disease. Here we are having two columns. We are going to analyze both of the columns, and we will see the correlation between them if there is any correlation. So yeah, this is the main purpose of using a ViolinPlot. So let's jump into it and let's analyze a couple of things.
So we have done the EDA for like each and every column individually, but we have do the EDA for the numeric columns like age, resting BTP, cholesterol, fasting BS, heart rate, old peak, and apart from that, we also do the uh, pie chart or analysis for the columns where we are having categories like chest pain we are having, and we have actually now the overall analysis how the all the things are distributed. Like we are having more number of male candidates there who are having the test. All of them are following the bell curve if we are removing the outliers, and there are more number of males then, and most of them are having asymptotic pain, and if we are talking about ECG, most of them are having normal. 60% of them are having, 50% of them is having ST slope flat, and 55% of them are having heart disease from this data set. Now let's discuss about something called as a violin plot. Okay, this will help you to analyze more than one thing at a time. Okay, for example, I have discussed with you, what if I want to know if uh, we know from this that there are more number of male than female. So is there any chances more number of males are positive or more number of males are not having the disease? So for that purpose, we are having something called as viral plot. We can use other plots as well. I'm going to tell you the very basic one. SNS dot violin. VIOLIN. Sorry. So here I also need to change. So this is a violin plot from SNS, which is Seaborn. Okay. So I want to do the violin plot, and here I need to define on which column I want to do this. I want to do this for sex column. Okay, sorry. So if I want to do it for one thing at a time, so make sure to do it uh, based on the means violin plot is kind of a distribution plot, so make sure to do it for something called as the age. Okay, let me tell you what will happen if I'm applying it on the age. It will make something exactly the same as the distribution plot. Here the middle dot that you can see is the mean or the average. Okay, what if I want to perform the same but on different kind of based on the gender? Okay, so can we do the same based on the gender? Yes, we can do that as well. For that purpose, uh, okay, this time I am taking the age, and this time let's make this violin plot for more than, where I am having in the x-axis I am taking sex, okay, and on the y-axis I am taking heart disease. Okay, and let's see what will happen in this case. So here you can see the violin plot. Okay, this is not looking great, so let's change the axis to y and x. So here we are checking based on sex, is there any chances that we are having more number of male positive or negative? Okay, so here 0 means the person is not having a disease, not having heart disease, is normal. 1 means he's having the disease. M means male, F means female. So that means there are more number of females who are negative, who are not having the heart disease. Very less number of females are there who is having the heart disease. But as compared to males, there are a lot more males who are having the disease and lesser males who are not having the disease. Okay, from this you have analyzed a very important point that males are having from this data set, males are having more chances of heart disease. Okay, males are more positive in heart disease, females are more negative in heart disease. Okay, this is something we have just analyzed from this data set only. We have not done anything different, we are just analyzing it. Okay, so same thing we can do for the age as well. Okay, because now we know that this happens, so let's do the same but with respect to age, and let's see if age matters or not. Sex, age for the heart disease. Let's take the age and heart disease. Okay, so if I'm talking about the people who are not having the heart disease, so they are having, so as you proceed further, so this is the maximum number where people are having negative, because obviously the positives are also there. Okay, so from here the graphs are almost equal, but there's one change which is here between the age 35 to 45. In 35 to 45, more people are there who have tested negative, means they are not having the disease, because here we are having this curve, but there are very less number of people there who are having the positive. Okay, and from the center we can see this is point that you can see is the mean value. Okay, so the mean age of a person, it can be male or female, is not having a heart disease is almost 50 years. Okay, it is almost 51 to 52 years is the average age of a person not having heart disease. And average age of a person who's having the heart disease is larger than that. Okay, it is almost 60 year, almost 65, 58 to 60 years. Okay, this is the basic difference that we have just analyzed. Okay, if the average, it means if the age is more, average age is more, so obviously the chances are more in terms of if a person is having a particular disease or not. Okay, same thing you can also analyze, because based on the violin plot we can do a number of things. So we are doing it based on the heart disease this time, which is 0 and 1. Let's do the same. Let me open the data frame first, df dot head, so that we can have multiple columns and we can analyze multiple things at the same time. So instead of age, let's take cholesterol, or let's take resting BP and see if resting BP plays an important role in this case or not. Should be resting BP, sorry. Okay, so resting BP might not play a very important role because both of the plots are almost identical. Okay, so it might not plays that much important role. Okay, and what else we can have? Okay, let's try cholesterol and see if cholesterol plays an important role or not. Okay, here you can see cholesterol plays quite important role. Means and this time if we are talking about the cholesterol, if the cholesterol is 0, so there are more number of I would say positive people are there who are having the heart disease. Okay, but if we are going up, so there are more number of negatives are there. So this is the reverse that we are following here. So this is how we can analyze these kind of plots as well. Okay, so this is the analysis that we are doing, which will help you to make the overall report. Okay, so what you have analyzed from this, so from this we have analyzed there are more number of females who are negative. Okay, and more number of males who are positive. It might be because we are having more number of males, so because we are having more number of males, obviously more number of male positives are also going to be there. Okay, so this is the basic plots that we are plotting. You can try another combination as well, like you can try age with the resting ECG, or if because mostly we are trying to integrate it with heart disease, so we want to means collaborate heart disease with sex, heart disease with different stuff, because on the heart disease is the main thing that we want to analyze, that is there any column which is mostly impacting on the heart disease. And here you can see sex might be an important column, okay, and age might be an important column, but only at this particular area. If the age is more, so obviously there are more chances that particular person is having it. And after that, if we are going above 70, though obviously the chances are lesser, because the distribution is also lesser. Okay, so this is the overall analysis that we have done so far using ViolinPlot, where we are using multiple columns at a time, two columns at a time, analyzing it and finding the correlation. Okay, now in the next lecture we are going to discuss about the exact correlation, how we can find the correlation between all the columns. Okay, and after that we are also going to analyze which features you can remove and which you can select. So that is something we are going to do in the next video. Take care, bye.
So I'm hoping you are clear with the concept where we can use a violin plot. We have plot a violin. We have actually plot a violin plot with different columns like heart disease or sex. So what you can do, you can apply by your own, like for the different kind of permutation and combination of columns you are having. So now we know how the different column works. If you want to analyze multiple columns at a time, how we can actually do it. But this time what we are going to do, we are going to discuss specifically about heat map and correlation, how we can find correlation between two columns. If one column increases, either the other one also increases or not, or if it decreases, what is the amount on which it is decreasing. So to find the correlation between them, we are using something called as heat map or correlation. That is something we are going to do in this video. So let's jump into it and I'll see you on the other side.
So we have discussed a lot about exploratory data analysis so far, like how to analyze the data, how to plot the distribution, how to analyze important information out of a particular data set. But now we are going to discuss about the correlation. Okay, let me tell you what is correlation. So for example, let's suppose I'm having a data set, okay, and in the data set I am having couple of factors, like I'm having the age of the person, okay, and apart from that I'm also having their birth year, okay, in which year he birth, and apart from that I'm having his salary in terms of LPA. Okay, let's suppose if a person is having age 24, okay, let's suppose 23 years this time, so his birth year is 1998. Okay, so these are just the factors I am writing, and I am defining, okay, his salary is, let's suppose, 5 LPA. Okay, we are having some other person whose age is 25, so his birth year would be 1995 6. Okay, and his salary is, let's suppose, 7 LPA. Okay, again we are having 35 year of age, or 35 years is 1986, that is much higher, and let's suppose the salary is 25 LPA. Okay, so from this data set we can add multiple rows into this. But if I'm talking about analyzing each column at a time, which is age, birth year and salary, so from here you can see if the age increases, then birth year obviously decreases, right? If we are having a person whose age is, let's suppose, 3 years, we are having a kid whose age is 3 years, so his birth year would be 2019 or 18. Okay, salary obviously going to be 0. Okay, so the more age a person is having, the lesser birth year he will have. Okay, from here we can analyze it as well. Okay, and the more age a person is having, the better chances of a person having a better salary. Okay, so from here, if we are talking about the relation between age and salary, so they are having a positive relation. Age and salary is having a positive relation. Okay, why they are having a positive relation? Because if age of a person increases, his salary also increases. From age you can also treat it like an experience. If the experience of a person increases, salary also increases. Okay, but if I am comparing it by age and birth year. So if age increases, birth year decreases. Okay, a person having birth year 2000 is having age 21. A birth person having age to 1998 having age 23. Right? So they are also related, but if age increases, salary increases. In this case, if age increases, birth year decreases. If birth year increases, age decreases. So they are also related, but negative correlation they are having. They are having positive correlation. Okay. In some of the cases, there might be chances that it doesn't make any change. Okay. If age is something like in some of the cases we are having, let's suppose is location where the person is from. Okay, so age has nothing to do with the location. He might be from Delhi, he might be from let's suppose USA, right? From age is having no relation with the location. Okay, so this is called as a relation. How we can define the relation or correlation between multiple columns. And to define the correlation, we are having a math function that we are having. So let's suppose df is my main data frame. Okay, what I can do to define the correlation, now the session is starting, it might be restarting, so it might take a couple of seconds. So what we can do to find the correlation between multiple columns, we are going to use something called as CORR. Okay, CORR will give you the correlation. Now named ESF is not defined because first of all I need to run the code again. Once the data frame is there, I can execute it. So from here what we have got? We have got the correlation. Okay, and I have got the correlation between age, resting BP, cholesterol, fasting, normal. So this is a string. Obviously we cannot find the correlation between a number and a string. We can find it with the max HR, old peak, disease. Okay, so from here you can see we are having couple of numbers. What are these numbers? So these numbers are like, if I am telling you the basic correlation. So correlation between this age and this age column is obviously 1.0 means 100%. If the column, this age column is changing, so obviously it is 100% dependent on age column only. So that is why the diagonal columns are 1.0, means they are fully connected, because resting BP and resting BT obviously 100% correlation. Okay, if I'm comparing the relation between age and resting BP, we are having 0.25, means if age increases, resting BP also increases. Okay, but the problem is it is 0.25. Okay, the more closer to it to 1, the better correlation it is having. So from here you can see it is having 0.25 means 25% correlation. Okay, it is not exactly 25, but we can treat it like that. It is not, it is correlated but not that much. Okay, the value near to 0 will give you almost 0 correlation. Like here you can see 0.09, almost 0, no correlation. Okay, and if we are having negative correlation, for example here we are having minus 0.38. Minus 0.38 means if the age increases, it is between age and max HR. So if age increases, maximum heart rate decreases. This is the mean of negative correlation. Okay, closer to 0 means no correlation. Negative, closer to -1 means fully negative correlation, means if age increase, max HR decreases. If max HR decreases, age increases. That is a negative correlation. Minus 0.38, that is why we are having negative. Okay, and if age increases and resting BP increases, obviously positive correlation. Age decreases, this the resting BP also decreases, obviously that is also positive correlation. Okay, if one increase, other decrease, then it is a negative correlation. Okay, the value close to 0, no correlation. Okay, from here you can see we cannot find some of the columns which are having very positive or very negative correlation. Some of them are having correlation, like we are having 40% correlation, 0.40 minus 0.40 between heart disease and maximum heart rate, but it is not a strong correlation. Okay, from here we can find the correlation between multiple columns. In this data set there is no strong correlation we are having, but in some of the data set we can find a very strong correlation. And the benefit of finding correlation is, let's suppose if age increases, okay, heart disease, chances of heart disease increases. Okay, age decreases, chances of heart rate decreases, and we are having, let's suppose, 95% correlation between age and heart disease. So the obviously I will not take rest of the columns. I will only take if I want to know, okay, if a particular person is having heart disease, obviously I will directly correlate with age. What is his age? If age is 90, obviously he might have it, because if age is having direct correlation with heart disease. Okay, here we are not having, we are just having 0.28% correlation, which is not that much. Okay, now it might be really difficult for you to analyze and going through each and every number. So what we can use, we can also use something called as a heat map. Okay, what we can do, we can use SNS dot heat map. Here I can define the whole data frame, df dot correlation. This will make a heat map. Okay, maximum correlation is 0.10, which is the diagonal elements. Minimum correlation is minus 0.4, because we are not having -1 negative correlation. Okay, so from here what we can analyze, if we want to know about this particular correlation pointed, we are having no column having such correlation. If I want to know about negative 0.4 correlation, if I want to check, so we are having in max HR and heart disease, we are having correlation 0.4%, means a negative correlation they are having. If one increases, another decreases, but we are having a correlation. This one is something we can take, this one we can take this one and this one. These are the four columns, four correlation we can take between max HR age, max HR disease, disease max HR, and age max HR. Okay, these are the columns that I can definitely take. Okay, so this is the basic, I would say, correlation that we can find using heat maps. Okay, again we are also having some other method, like we can use PairPlot, that we are going to discuss in the next lecture. So yes, that's pretty much it, and I'll see you in the next one.
So I'm hoping the concept is clear about the heat maps and correlation, how we can find the correlation, how we can plot a heat map, and how I can analyze the heat map as well to see if there is any correlation or not. We are going to discuss specifically about PairPlot, where we are having the correlation. If you want to find a correlation between just two columns, and how we can find the correlation between them, if they are correlated or not, if they are, how much correlated they are, but just for a pair of two. Okay, so let's jump into it, and I'll see you on the other side.
So we have discussed a lot of things about exploratory data analysis for this particular data set only. Okay, same thing you can apply on another data set as well. So now I'm going to tell you about a pair plot. What is pair plot? So earlier we are working on joint plot, where we are taking multiple columns at a time, two columns at a time, and we are plotting the graph from it, like we have done on this joint plot, x and y. In x we are having age, in y we are having max HR. This is the distribution of age, this is the distribution of max HR, maximum heart rate. Okay, but this is something we have seen from the correlation, that they are having maximum correlated. So let's plot the graph from it, and let's see if the regulation line fits or not, and it is fitting. But how we can plot all the graphs, all the possible combinations? For that purpose we are having something called as a pair plot. How to work on pair plot? So pair plot, SNS dot pair plot, and inside that I need to pass my data frame, where the whole data lies. Okay, once I'm having the data frame, we need to execute the code. Okay, the problem with this is, if we are having multiple columns like 50, 60, 80, 100, 1000, So then it might run out of the memory because it is going through each and every combination and plotting the graphs for it. Okay, so now if I'm so it is same like the correlation. Like here we can see the in the correlation we are having the graph between age and age. So this is here, age and resting BP, this is here, age and cholesterol, this is here, cholesterol and age, this is there. Okay, here we are also having the same thing, but instead of the correlation number we are having a plot. So between age and age, this is the graph. Okay, here you can see all the diagonal ones are exactly the same. Okay, but we do not want to take we don't want to take care about the center one. We want to take care about the distribution, overall distribution, how it is following. Okay, and if we are going through this particular distribution which is between age and max HR. So from here you can analyze it is starting from the top left and going towards the top right, which is exactly the graph here. But here it is max HR and age, just the reverse of it. Okay, max HR and age. Okay, or you can also take age versus where is the max HR. Okay, that's the graph. This one and this one almost the same, no change. Okay, from here we can analyze another graphs as well. Like if I'm analyzing this, so in max HR and cholesterol, what is the correlation? Is there any correlation? Max HR and cholesterol, max HR and cholesterol, so they are having somewhat positive correlation. Okay, and max HR and cholesterol, if I am plotting the graph between max HR and cholesterol, and if I'm plotting a fit line, it will fit as well because I'm having somewhat positive correlation. Obviously spelling mistake. So I need to write the correct spelling. And if I am fitting the regression line, this is how the line fits. It is not exactly how it should fit because it is not fitting the best. It is not going for the best fit, but at least it's going through the origin. Okay, and the correlation that matters is almost 70 to 80%. If they are having minus 0.7, less than minus 0.7 and more than 0.7 correlation is there, only that correlation matters. The rest of them are not that correlated. Like here you can see it is not exactly correlated, but we have find some of the correlation between this. Okay, so this is the pair plot. As I've told you, if you are having very large number of columns, then it might run out of the memory because it is plotting a lot of graph. It is doing a lot of computation. First of all, it is plotting the graph between age and age, then uh, age and resting BP, then age and cholesterol, then age and fasting BS. So it is doing all the combination. And if I'm calculating 1, 2, 3, 4, 5, 6, 7. So 7 cross 7 means it is plotting 49 graphs out of it. Okay, and it will help you to do the correlation. In this data set, the data set is not very much of correlated through which so that we can drop some of the columns and take another one. But yes, this is very good to means train you how the things are working, how you can go for the pair plot, how we can go for the joint plot, how we can use violin plot. Okay, in which case which particular plot is best for you, how we can find the important insights of it. Like we have find from this, we have found from this, like in this particular area there are more number of people who are not positive but they are tested, but here they are not there. But in this particular case obviously it is there, there are more number of negative, more number of positive. The average age of positive people are around 50, and negative people are around 50, positive people are around 55. Okay, these are some of the things that we have analyzed which is not actually given in the data set. We found some important insights from it. So this is how you should perform EDA. We are also having some advanced aspects of it, which comes under exploratory data analysis, where we are fitting the bell curve if we are having less number of male or less number of positives, a more number of negatives, or if data is imbalanced, how we can deal with it. That is also something can be done, but we are not going to discuss it today or in this particular project. So that's pretty much it about this particular project, and I'll see you in the next one then.
So now we have discussed about what is the correlation between maximum heart rate and heart disease and other things. Okay, and from here we can actually plot a regression line, which will actually tell you if based on something we can analyze the output or not. For example, if we are talking about the heart disease, so as the maximum heart rate increases, okay, as the maximum age increases, maximum heart rate also decreases. This is the correlation that we have just found from the dataset, which is an important insight that we have gained from the dataset. You can also find more such insights from it. And yeah, that's pretty much it about from my side. If you're having any question, please let me know. We are going to discuss about joint plot, like how we can actually find the correlation between all the columns that we are having. Like in this particular case, we are having 7 columns in the category in the numeric type, where we can find the correlation. So 7 by 7, so we are going to make a total of 49 graphs. How we are going to make that 49 graph, how we are going to analyze those 49 graphs, that is a question we are going to answer. So let's jump into it, and I'll see you on the other side.
So we have discussed about a lot of things. So let's discuss about the last step that we are having in EDA. But before that, let me summarize what we have done. We are loading the data. To do the ADA, we are having two types of column. We can have the numeric, where we are having numbers. We are having categorical. Okay. So first of all, we have discussed how we can perform EDA on distribution plot, using distribution plot on numeric ones. So we are taking cholesterol, resting BP, age, and max HR. Then we have performed it on categorical one, like sex. We are having resting ECG, pain type, heart disease, and ST slope. Okay. Once we have all those things, we have also performed the ViolinPlot, where we can take pairs and after that do the distribution. Okay. And from here we have analyzed multiple things, and then we at the end we have discussed about the correlation. Okay. From the correlation, we have found some very interesting points. That is, there are some of the columns that are correlated. Okay. If I'm talking about negative 0.4 correlation, so we are having this column, age and max HR. In age and max HR, we are having correlation. Okay. So let's see if that correlation is also actually there or not. How to see that? For that purpose, I'm using one of the plot that I'm using is JointPlot. So I'm writing SNS dot joint plot. Once I've written this, then I need to define what I need to add in the x-axis. In x-axis, I want to add age, and in the y-axis, I want to add maximum HR. Okay. Once that is done, because here I have not defined the data frame, so I also need to define the data should be data frame. Okay. And so far, just execute it. And from here you can see this is the distribution of age based on max HR. Here age is this one, okay, and max HR is this one. And from here we can see the graph is starting from here and go towards this side. Okay, and because it is toward this side, and that is the only way to which it is showing you, okay, this is having some correlation. Okay, if I'm doing the same but with some other one where I'm having almost zero correlation, let's change age and age. What is the correlation? It will take some time. So in age and age, we are having totally perfect correlation, because if the age changes, obviously we are having some other column which the same age, obviously they are having 100% correlation. That is why they are on the right side. Okay. If I am taking some of the column where I am having almost zero correlation, like this one I am having, so let's take this one, between heart disease and old peak. let's take these one. Okay, so let's take hurt, this is and OLDPEAK. If I am doing on this, obviously I'll have a spelling mistake. Old peak, that is okay. This is hurt, this is okay. Old peak is okay. So what is the problem? Hurt, this is okay. I need to check the column name then. Okay, so P is smaller, I think that is the issue. Yes, now it is plotting the graph. So from here you can see there's almost no correlation between both of them, because hard disease is zeros and ones and old peak is a continuous value. Okay, so obviously there is almost no correlation. And let's take uh, cholesterol with it, because this is for that purpose I know that this is having a continuous value. Let's take cholesterol with this. So this is the correlation, and here you can see it's almost random, no correlation is there. From here we can see some correlation. Okay, and let's see how we can actually verify if there is a correlation or not. For that purpose, actually in this graph as well, we can do different kind of plot, different kind of visualization changes. Okay, for example, if I'm writing the kind of graph should be a hexagon. Okay, so it will make hexagons. Okay, from here you can analyze it. Okay, it is starting from the top left, it is going towards the top right. From here you can also see the graph of age distribution, and here you can see the graph of maximum HR. So this is where, in this particular area, where the whole data converges. Okay, because here we are having the darkest points. So this is where the data converges between maximum HR and age, maximum heart rate and age. This is when the the people are having maximum heart rate. Okay. Now, what if I want to see actual correlation between them? So to see the correlation, I'm going to draw a regression line. Okay, I am going to draw a regression line. How I can draw a regression line and what is a regression line? For that purpose, I am defining kind is equals to reg. Okay, let's define kind is equals to reg. If I'm executing this, so this will draw an actual regression line, how the data is flowing based on age, how max HR is changing. So this is the best fit line that model has drawn, this one. Okay, and through this best fit line, from here we can analyze if the age increases. If the age increases, so the maximum heart rate will decrease. From this data set we have analyzed it. Okay, same kind of things we can perform on some other plots as well. Some other factors or some other columns we can take, like what are the other things where we are having. So we are having, let's take this darker one between heart disease and max HR. Heart disease and max HR. Okay, we have done it. So let's do it with cholesterol and fasting BS. Okay, can we do it for cholesterol and fast BS? For that purpose, obviously you need to plot the graph first. So it would be cholesterol and fast BS. So in fast BS we are just having 2 to 3 columns, so that might not give you that good correlation, because here we are having a number, but let's give it a try. Otherwise we will take another number as well. So if I'm drawing a regression line, so this is how the regression line fits, but this is not how it should fit, because some of the data is at the top, some of the data is at the bottom. Here the line doesn't fit the data. That is why there is no correlation. Okay, And here we can find the correlation because here we can see the data is the line is flowing through the data. Okay, and let's take the last correlation that we can say. Let's take heart disease and max HR. Heart disease along with max HR. So from here also you can see this, at least this is flowing through the data, because if we are comparing the heart disease, because like here we are having either 0 value of heart disease or 1 value of heart disease. If the heart disease value is 0, means if the person is not having a heart disease, here the density is at the top. Here we can see the density. Okay, and here you can see we are having lesser number of value, here we are having more number of value. This is where the density lies. Okay, if the person is having the heart disease, so the density lies here. Okay, means the maximum heart rate somewhat impact the heart disease. Okay, so this is how we are plotting the pairs, like in two pairs how we can plot the graphs. Now next we are also having something called as joint plot, where we can pair plot, sorry, where we can do all the plots in one line only. Okay, and after that we can analyze each and every plot, and that would be better, because uh, every time you are not going to do all the permutation and combination about the graphs. Okay, age and resting BP, age and cholesterol, age and fasting, you are not going to write the code for displaying each and every plot. How you can do all the things with just one line of code, that is something we are going to do in the next video.
So I'm hoping you are clear with the concept how we can plot the joint plot, where we are having all the possible graphs, how we can find the correlation between them, and how we can see which graph we should take, and what is the insight that I can find from those particular data sets or plots. So this is an end-to-end project that we have done on heart disease analysis. If you are still having any question, make sure to ask. If you can analyze more things from it, then obviously just add it in the comments, that what are the things that you have analyzed apart from the thing that we have discussed in the video. Okay, and as I've told you, if you are still having any doubt, do let us know in the comments. I'll be more than happy to answer it. And yes, that's pretty much it. I hope you enjoyed it. If you enjoyed, make sure to hit the like button, subscribe to us, so that because we will come up with more such videos, and we'll have an idea, okay, you like these kind of content, so we'll put more efforts into this. And yeah, that's pretty much it, and I'll see you in some other video. Take care, bye.